here is an example. If we have already been given a matrix A here, and if we want to find sine AT and cosine AT, what we need to do is to enter A first and declare T as a symbolic variable, and declare J as a symbolic variable for square root of -1. Then we can easily use the formula to find sine AT and cosine AT, and then we can simplify the result. And with the use of ESPM function, we can easily find the sine and cosine functions of a given matrix, and the form could be rather complicated, but we can find finally the results. So this kind of result, you can be seen that we are trying to solve the problem with hand. It could be very difficult. However, with the use of computer, we can easily find the task, do the task, perform the task. Okay, so these are the exponential functions, sine functions, and cosine functions. What about other functions? For instance, how can we find the solution to this one? I don't think there is any existing method which can be used to solve this one, and there isn't any routine to solve this one. So, based on the Jordanian decomposition or transformation, I write myself a Matlab function. This is called FUNM, which can solve this kind of problem. So here I am not going into too much detail about the mathematics of this function. So just to tell you something about the interface. How can we code this function? So the 3 pages are the functions. And the function should be placed under the anything directory. So I will explain how we can use the function. Suppose A is the original matrix, is the matrix, and this one is a string which expresses the function to be evaluated, and X is the independent variable. And then they can solve the problem easily. Let's write down the composite function. The function I want to evaluate is something like this, cosine AT. And in Matlab, we can express this one by exp x replace A by x times cosine x times t. So for the expression, for the FU and X expression, I can use this string to express the final function, matrix function. So the function call is now something like this. Declare X and T symbolic variables and enter A matrix. Then we can use this function and this part to describe the matrix function in a simple way, where X is an independent variable. And finally, we should use A to replace the X variable. And with the use of the function, we can easily find the quite complicated matrix function like this. Find the composite function easily with the use of FU and M. And it can be seen that terms are quite complicated. This is the first column. And the first column is quite long, but it should be accurate enough. In is an analytical solution. So this is the upper left corner term. The right is the mathematical way to choose the measures. And we can find easily the composite functions. So we have concluded the chapter on linear algebra. And in this chapter, first introduce the way to represent special matrices in Matlab. And then we explain how to analyze the matrix by finding the determinant, the trace, and other properties of the matrix. And then I explained how can we take inverse, pseudo-inverse eigenvalues of the matrix. And then I explained how to perform decompositions to the original matrix. And also the similarity transforms of the matrix. Then I explained something about solutions to matrix equations such as algebraic equations, the Lyapunov equations, and others. And finally, I explained how can we find exponential functions, exponential matrix functions, triangular matrix functions, and arbitrary matrix functions. So this is the main part in this chapter.
Yeah, that's here. That's actually what I did with my hand. That's a whole different set. I just ran one real big one.